Good evening, sir.
Grant you a gun. Grant you. Come
What I
on.
said, sir.
Mr. Wagon grant you or things.
There, man. Things are alright, man.
Mm.
How
You
about
check
you?
it. Well, say I was up doing that working for one deadline and go bed 3 o'clock this morning and then wake up at 5 o'clock and go work and come back in and I will sleep a while I can dream, so I'm late for class and jump up. But weird, don't.
Wow.
When man I go
Yeah.
sleep, man for to sleep, don't.
True, that's it.
Ja, ja. I mean, no, like, oh goodness, man, is asleep, is asleep, Ja.
You just didn't want to say.
Yeah, how many other guys am there? Well, it's only 18 past, so they good otherwise though.
Yeah, man, sir. Oh, by
When
the
you
way,
able to,
sir.
you check online?
In my grade, yeah, I'm check it.
Yeah, good.
They do want the A still, but me will take that.
Yeah, I mean, me proud of that. Gonna be otherwise don't. Yeah, man, you did pretty well. You have an opportunity again now though to shut it up.
Yeah, man, we'll try, sir.
Yeah, man. Be nice if you in this group. So I'm gonna add you. Remind me to add you to Etiquette before we leave tonight. You hear?
All right, sir.
And send us something in the group now. Say the man and say rope in.
Good evening, sir.
Hey, Aston, you sound much better. Thank you, Jesus. Well gone.
Sound much better, feel much worse.
Trust me. What I'm gonna say to you, don't because I had a relapse, you know. So don't continue taking the vitamin C even when you feel a little better. Trust me, because I guess this is what this thing want. Saying I catch them now. Never mind. See if I can put on some tea. You just reaching?
Having some electrolytes. So the tea might be later.
Listen to me. You know, said, is that make me feel which of the electrolyte you drinking? I had Powerade.
Coconut water.
Okay. No, well, I had for the last couple of days, I just started drinking those bottles and bottles of Powerade, and trust me, it worked. Yeah, man, it worked, man, it worked, it worked. All right, I'm just waiting until how many of us are now?
Sir, you
Uh,
never send the homework, you know.
you know, Aston, that's exactly what I'm looking at now.
And we ask you for it and you didn't respond.
Wait, aspect in the group, in the WhatsApp.
Yes, sir,
Yeah.
I did.
Jeez, when was that, Mikey?
It was the same. I think it was the same evening.
No,
Or the
man,
evening after. I think it was the evening after.
no, no, man, at the same evening. I'm going to know what happened. That would have been Wednesday, don't? Wednesday. No, Wednesday. Yeah, Wednesday.
Sir, I sent you a message in the chat.
I'm going to look at it. Oh, I know what I did, you know. I know. You recognize that the recordings are uploaded, all right? Cool, Mikey. See that? Whoa. Um, that's so like Florida. Here? You Mikey?
Sir?
That's so like you're going to Florida.
No, sir. No.
Yeah, but I think I know what happened. I uploaded the recordings and said I was gonna do something. I'm gonna send up the stuff and then yeah. So I'm trying to look at it and it's like, what was the last example I give to them? And I can't find it. And then I said to myself, oh, I never um copy of the stuff. So that's what I'm looking for now. Don't worry about it. No worries. You'll get them today in abundance. What we did though, it was a trapezoidal rule, don't?
Yeah.
Yes.
Yes, sir.
Trapezoidal. Um, oh, I remember now. So actually, when you remember the conversation, the direct conversation you and I were having,
Yeah.
right? So you had asked for the stuff at that point in time. I didn't know what everything was looking like yet, so that's why I didn't respond to your request at that time. And it was after that that everything was sorted out. So it wasn't Wednesday then. Yeah, it wasn't Wednesday, it was Monday. You asked it for Monday. It was because Wednesday the stuff went in Wednesday morning. Yeah. Whatever it is, I'll get it sorted out. What is it called? MATH4702.
So you accept student calls on weekend?
I do actually. I do. I'm kind of different from others, I do accept calls. Hey man. But do you make calls on weekends?
I intend to call you.
No problem, my love. Me know what you said to me the other day privately, a bixy, but me not pay you no mind. So if it's anything,
Anything you say, sir.
I hear you. Oh, the man them there. Trapezoidal rule. What's your I sent myself something on trapezoidal. Oh, interesting. I sent myself something on trapezoidal
I think
today.
Oliver is sick, you know.
Speaking of which, I have not seen him come up from Monday.
He's been having some issues. He has not been feeling well since this week.
Reach out to me. No, no, me for call him no. Me for call him no. I'm muting so me can call. No. SMS, just shoot me a WhatsApp of his number now, please. I don't know where I can find it. Just send me a number, a pick number for him now, please. All right, I guess him no want to talk. The call twice and the calls were ended. So we will see what will happen. All right. Okay, I think he just sent a message. Oh, okay, so he has responded. So try calling back. Oh, sorry, let me call him straight then. His internet is down. Okay. Him really not well. All right, give me a minute. I'm just gonna link up with him. I'm gonna call him straight. All right. He's unwell, so we just have to keep him in our prayers. Guys, trust me, make sure you're taking a vitamin C. Make sure you're taking the supplements. Things are just happening. I don't know what is in the atmosphere. Things are happening. All right. I want to drop some more. We're finishing off the they call it that same topic there. Finishing it off today. Finishing it off today. I just want to, oh, I know where I want to go. I'm going to ask in the meantime if anybody can find past paper questions. We need to start immersing ourselves into past papers. I know I showed you one, I think a 2019. That's the one I'm looking for now, and somewhat having a difficulty finding it, but finding it. So that's what I'm looking for now. But we need to get some past papers. So in the meantime, I'll look back at the question. I'm going to ask you to do find some past papers, please. Where is it? I know I did. See, there's something here, man. What is wrong with me? I'm from the past or something. Sure. There's something there right here. So this was applications of integration. Just reminding that outside of the ones who are just coming over for calculus 2 that are at to Educasoft, remembering those of you who already have access to it, Educasoft is up and running and behaving very strong. Please, I want you to be able to successfully complete calculus 2 again. Congratulations for reaching here. Especially congratulations to the ones who are just coming over. All right, this computer is moving sluggish. Oh, I could have done that too. I never thought of it. Could have done that too. Since it was previously downloaded. Let me run for oh yeah, but I just closed this document. I closed it. I missed it then. Okay. With that question. All right. And we'll do it. So we're down to the past people now. And then right. Good. Okay, so I have a few questions here, and I'm going to see if I can mix it up and give you maybe like an exponential function in it. Yeah, man, I want to look. Don't want to look autumn. All right, cool. All right, so let me just go project this one then. This one is the past paper. And then when I project it, I'm gonna give you an opportunity. I'll just put this down here. I'm gonna give you an opportunity to try it on your own. There goes a question. And there's a reason I want you to. I don't want to immediately work the question with you. Yeah, I don't want to immediately work the question with you. I want to see how best you can decipher this question on your own. So I'm going to ask you to give it an attempt. Give it an attempt, and I'm right here. I have nowhere going. But give it an attempt, and then we can together work through it. I'm looking forward to. I never do any much housekeeping with you, because you guys are here because you would have conquered the lower level math course. I don't want anybody to come over to Calculus 2 and form full of themselves. Right? Don't get complacent, because the Calculus 2 can get rough. I'm being very honest with you. The concepts can get rough, and this is why I'm trying things a little different. I've never started Calculus 2 at applications to integration. I've never. And I'm just following the leading. When Father God say, yo, start right here, sir. And I'm doing that. And I'm hoping that it will bear lots of fruits. So I want you to work with me and just do the things that I expected of you. Once you work with me, you should be good to go. So look at that, make an attempt. The idea is not to get it right. The idea is to give an attempt. If you give an attempt, ain't no workout, it's fine. If you give an attempt and it work out, hooray. But I want you all to give an attempt at this question, all right? So I'm gonna mute, give you a couple of minutes to just sort out yourselves with it. And then, and if you can't do it, don't beat up yourself too much. This is just week 1. All right.
There you have something blocking the screen. Thank you.
Always stay, always feel. Anybody have an idea? Is it frustrating? Anybody know what they're talking about?
I am thinking that one of the X is upper level and one is lower level. But then I don't know what to do with the
Very good thinking.
and I don't know what to do with the Y. So I'm trying to read to see if I can.
What do you mean y? The y equals x squared plus 2?
Yeah.
Okay, what do you think you do with the y estimate? Don't even read. You don't need to read.
I
I
find
know
the equation.
what is the y? The y is a what?
Repeat that for me.
What is the y? Can somebody tell me what the y is, please? The y equals x squared plus 2. What is that?
The Y is the area of the plot of land that we need to find.
It is a function for the plot of land that describes the plot of land. So what are we going to do with that function?
We're gonna keep it, but it's gonna be the answer.
No.
All right, chat.
Yes, go ahead.
All right. VFX. I don't think we need to work that out because we see it as a half already, sir. I don't know if I'm correct. I came in the class late.
So why we don't need to work with the VFX?
Sir,
No, talk to me.
them increment by a half right here, sir, on the x-axis.
Oh, so you're saying that them give it to you already?
Yes, I'm assuming those are ordinals. I'm not
Okay.
sure.
All right. All right. So go on work it out. I like the thinking. Go on work it out. Very nice. Anybody else? All right. So I know what he's talking about, but I want to give the rest of you an opportunity to look through the question. I think I have 2 additional questions to give you. I think I found one, an exponential one, but I also need to find others. I'd love if you can put your hand in a past paper or 2 can go online and catch up past people so we can just work it up. It's now 7 p.m. I'm going to give you another 5 minutes to figure it out, and then I'll come back to you. And I don't want you to just figure it out. I want you to put pen to paper, and I want you to actually start working on some stuff. So that when I'm working this stuff, you can say, yeah, I was on the right track or I was a little far off, all right? All right, muting. Right? Go to 5, give you 10. How are we? How feel about it? Where are we on it on this one now? Too early in the semester for we not talking and answer me, you know.
Sir,
No,
me just read home, sir.
Trying to do the submission. So with what Shavai had said and with what I had said, I kind of combine both of them. And I'm looking at the 1 and the 1.5 going across to be the ordinance. So I using n equals 6 based on the amount of ordinance that we're given.
Okay, so some progress is going on.
Huh?
I'm saying some progress is going on.
Start doing the substitution now.
Okay. I like the sound of that. Mikey, you say reach home now?
Yes, sir. Just reach you.
Cool. Kevin, you finish your question now?
Yeah, so get an answer here, me open your Victoria King.
Okay, what answer you got?
28.
You got 28.
No,
All right.
28 and 5/8 units.
28 and 5/8 units squared. All right.
Yeah. That's square.
All right. Remember, it's always units squared or squared units.
Yeah.
Once
Yeah.
you integrate, once you integrate it. All right. I like the effort, and I'm going to tell you why I like it. I don't know if you're right, you know. Well, maybe I do, but play along with me. Don't know if you're right, but if I look at the other part of the question, it says if the direct integration gives the exact answer as 27 square units, find the percentage error in your answer to one above. Error. All right.
That means our answer is not 27 then.
I'm not saying I'm not well, I don't know what you want to get from that. Tashi, let me hear what you say. I don't know what you want to pull from that.
Sir, for the first part, I got 27 and 3/8 units. I'm not sure if that's right.
No problem. Name. Sheffy says you get 27 and 5/8, you get 27 and 3/8. All right. Okay, continue. I need to hear more. Oh, yes, guys. Waiting on the rest of you to tell me where you are. I don't want to just jump in it yet. What about the rest of you? I heard from Granty, or stay?
Good, sir. I get 217/8 units square.
217 divided by 8. That's 27 and 3/8. No. You say 218
217.
or 217? Okay. All right. Hmm. All right. So three answers, three different answers, but the three answers are in close proximity. One of those answers is, I think, is correct. I want to hear from the rest. Simon, come talk to me.
Sorry, I fell short of at 22.7 units squared.
You got 22.7?
Yes, sir. I'm trying to recheck and see where I went wrong.
Okay.
I got 27 and 1/8.
You got 27 and 1/8. All right, so two of you got the same answer. The two students have the same answer. After the way say. Come on, guys, talk to me, no man. I don't want to just jump in. I want to give everybody an opportunity to. All right, so Mikey just reached in. I got Aston, I got Chevy. Shamari gave me his Simon work on it. Taj, you know, talk to me, Taj.
Yes, one, sir. I mean, you said 27 and 3/8 units.
Yeah, you did. Tristan, what you say? Utterly. They say to earn at the semester when I call upon one and answer me. The semester started Monday. Answer me and tell me say don't reach nowhere, but don't make me have to wait for no. All right. Ready or not, here I come. So it says the sketch below represents the area. By the way, All right, let me continue. Will represents the area under the curve y equals x squared plus 2 between x equal 1 and x equal 4 of the boundaries of a plot of land purchased by ABC company. The length of the perpendicular offsets, which are at equal intervals, from the straight line to the curved boundary are shown on the sketch. The field manager of the company would like to know the area of the plot of land before using it. Interesting. This is how real the mathematics is. Those persons who are in construction, project managers and developers and them, some people there, they need you. They need us so that we can tell them how to maximize their land. Nobody wants to build and not being able to maximize. So it's a practical question. But my solution though is of course, recognizing that I have my answer to the question I was asking is that x squared plus 2 is the function for which you're integrating. So don't worry about that it is y. The function that it is y, just like how you name Astenil and Simon named Simon and Tajay named Tajay. It is just the naming of a function. X squared minus 2, x squared plus 2, sorry, is the function. And the function is called y. The function could have been called f of x. So don't worry about not knowing what the y is. The y is a function for which you are going to be integrating. That is the area. That is a function that defines the area under the curve. All right? Now, where was I going now? Right. So remember, you always remember when you're doing your trapezoidal rule that the first and the last ordinal is only touching one of the trapezoids. So those are going to be multiplied by 1. The other ordinals are going to be interfacing or touching 2 trapezoids. So they are going to be multiplied by 2. The base of the trapezoid is going to be touching that ordinal. So therefore, the other terms are going to be multiplied by 2. You remember you're changing x. It's going to be your upper limit minus your lower limit. Very good, Astiel, to recognize that the x equal 1 and x equal 4 are the limits of the function. And of course, the bigger one is going to be the upper limit, and the smaller one is going to be the lower limit. Now, I hear Chavoy talking about some stuff. I don't have a clue what it is that he's talking about. Or maybe I do. So we are going to do the question like how Sir showed us how to go about doing the question. We need to find the width of the trapezoid. We need to find the width of the trapezoid. It's b minus a over the number of trapezoids. But hold on. Did they tell us how many trapezoids we have?
Not directly, sir.
They didn't tell us directly how many trapezoids we have, right? But how can we figure out how many trapezoids?
So it
Sir,
says
we
that
count
the
the
length. Go ahead.
well, I'm sorry, we would count the spaces between well, the spaces between lines that I did, I got 6. And for the ordinal I got 7. So I just use 6. That's what I did.
All right. All right. So you're saying that. So how many ordinals you have, Mikey?
7, sir. Tajay.
Tajay, sorry, I keep saying did I not say this the last time around? Yeah. Una come from the same parents. So so much alike. But anyhow, yes, Taj. So what you count off, Taj? Talk to me.
I count the spaces between the lines so
So
I
to get the
counted.
trapezoids,
Yes, sir.
I get 1, 2, 3, 4, 5, 6 trapezoids,
Yes, sir.
and then 7 ordinals.
7 ordinals. Yes, sir.
All right. So you look at this thing. So you're saying then that is going to be B minus A, which is 4 minus 1 over
Over 6.
6.
Yes, sir.
Because it's 6 trapezoids. Okay. Do you agree with what Charles is saying?
Yes, sir.
Yes, sir.
Yes, sir.
And students, hear me out. I am doing this. There's a different way of teaching in an online space than when you are doing the face-to-face. I am asking these pointed questions because I am not seeing, I'm not seeing you, and I want to make sure that you are understanding. And I'm liking what it is that I'm hearing. What I'm hearing is sets of students that are understanding what it is that the teacher has presented, and I'm liking that. I'm really liking that. I'm going to pause to encourage somebody. If you're a teacher knows from the very first class a student who is going to pass that class. At the first class, the teacher knows which student has the potential to improve, to pass. And at the first class, the teacher also knows which student is just going to bluff and not do any work. Hear me out. I know you guys like the online. There are 2 of you in the class. 2 of you in the class that are joining us from out of town, out of Kingston. And those students have been doing very well. Actually very proud of those 2 students. But I'm going to give you a word of encouragement. And it has nothing to do with the teacher. No. I mean, whenever I'm speaking about my students, I don't put myself up there first. My students do very well. It's not because of me. I'm only a channel through which my students perform. So really and truly, when you're at the university level, you see how I'm teaching you? If I was taught like that when I was going to university, I would have been a scholar. You are presented with the information one time, you go research the rest of it. The university gives you 20%, and you have to go find the 80%. No, sometimes me take me in a 95%. I'm gonna go over. So we can't get it. It does not happen like that at university. And you may say to me, but sir, we're not a university. Yeah, you're right. But we're still offering the product of the university, which is a degree. So my word of encouragement is, I remember some years ago in COVID, I was teaching a group of students Cape Integrated Math. And the students in the class did very well. I think I sent up 20, don't quote me on the numbers, either 23 or 25. But if I sent up 25 of them, 23 of them pass. And if I sent up 23 of them, 21 of them pass. Only 2 students failed. 2 of the students who failed, I knew they were going to fail. All right? One just never come to class. Point I'm making is, you don't come to class, you are going to have a challenge. Other moral of the story is, when you come to class and you sit and you don't participate in class, you are going to also have a challenge. And let me tell you why. And I think I want to do a paper or something on this because I have proven it. You see, when Chevoy had that idea a while ago and we don't get to Chevoy's idea yet, you know. Chevoy has an idea, and Chevoy sits with him idea and said, Trump, I say nothing here because Me know what me having in my headspace right. And Chef sit down and don't ask me nothing. Class done, and Chef is still holding on to his concepts. Chef may have a misconception somewhere, but he's hoarding his concepts. And he hoards it, and he hoards it, and he hoards it. He never shared it by participating in class and speaking up and questioning stuff. And then Chef has a misconception, goes into the exam, produces a misconception, fails the course. That's why speaking up in class makes it, and in particular an online class, because when you're in a face-to-face class, if any of you have ever been in a face-to-face session with me, and I don't think any of you have been in a face-to-face session with me, I don't sit down at my desk. I walk up and down in my class and I look into your books and I look to see what it is that you're doing. Chef, if you don't believe me, go ask my friend, right? That's how I teach. So in the online space now, I have to be asking these myriads of questions just to convince myself that you are understanding what is happening. And at the end of the day, one of the students got a distinction, and quite a number of students got grade 2s. With a little bit more effort, they could have gotten their distinction. And when I saw the distinction, I remember calling the student, and I said, "Yo, you get a distinction, man?" He said, "Yes, sir. I see it from last night, you know." And the youth laugh. And I said, "Why are you laughing?" He said, "Sir, because you teach me Cape Math online. I've never gone to one of the, I had 2 face-to-face classes. And he never attended one of those face-to-face classes. And he said to me, "Sir, I've never attended one of your face-to-face sessions. And I got a distinction." I said, "Very good." And the end of that story is even sweeter. He was placed 20th in the island, or 21st. Either 20th or 21st, a long time, so I remember. But he got a placement from CXC in the island. He might get a higher grade than them people from some of them top schools, Immaculate and Campion, and them placed there, right? What's the moral of the story? It can happen. You can learn in an online space. It's the same teacher him have, it's the same teacher you have. You can learn in an online space. Some of them want to come to class and I talk to one, I hear the same set of people. Chevin afraid for talk, Aston not afraid for talk, right? Tajin afraid for talk, Mike not afraid for talk. Well, the rest, this class not afraid for talk. But speak to me. And when I call upon you, talk to me. I'm calling upon you because I want to find out what is in your headspace. If it is correct, I can build on it. If it is incorrect, I need to erase it and start the building process again. You guys understand where I'm coming from now, why I keep asking you questions and I want you to talk back to me?
Yes, sir.
Yes, sir.
All right, let's pick up on yourself then. All right, now, so my changing, and I'm gonna go back. I still don't know yet what Chevy is talking about. So I agree with Tajay. Taj says to me, Tajay said that this is 1, 2, 3, 4, 5, 6. Me see the 6 trapezoids to read. Me see them. So we can't debate that. So I hear Chevy talk about 1 and 1.5 and them something. I don't know where he's coming from. Matter of fact, Chevy, what is this 3 something and 4.25 and 6 and 8? What them something, Chevy?
Yeah. Ordinal, sir.
And that you get the ordinals? I don't know what you're talking about. Anyhow, we soon come back to you, Chef. So he might talk about ordinals, and I don't know what I talk about. So make we do this, make we do the question, oh sir, teacher, offer the question, because Chevy not pay attention in the class. So we're gonna teach Chevy something today in the class, right? So the change of x over 2. It's b minus a, it's b minus a, 4 minus 1 is 3, and 3 over 6 is a half. That means I'm correct. Because the width of the trapezoid is a half. Everybody see the half?
Yeah.
Yes, sir.
Yes, sir.
That
Yes,
means
sir. Mhm.
that means it should be right. That means say if the width of the trapezoid is a half, that means if I start at the lowest one, which is 1, then the next one is going to be 1.5, then 2, then 2.5, then 3. Oh, all right. Okay, Chevy. So I agree with you right here, so Chevy. All them number you come now, the 6 and the 8.25 again, Chevy. When did them be?
When you substitute, you get those.
You sure?
Positive.
All right, let me check. 1 square is 1. 1 plus 2 is 3. All right. 1.5 square is enough. And that enough plus 2 is 4.25. All right, let me try the other one. 4 squares are 16. 16 plus 2 are 18. I'm right, don't? Everybody agree with Chevy?
Yes, sir.
Very nice, your boy. I'm happy that you're able to see that out of the bat. And of course, you were paying attention and you know what you're talking about. Very nice. Shamari, go ahead. You're saying something?
No, sir, me just that this out a lot, but sorry.
Yeah. So it's very nice, Chef, to see that you are able to quickly glance at what is happening. So what's the moral of what I just did a while ago? I could have agreed with Chevy from he said it because I knew he was correct. I could have said it at that point. But if I had responded to him, the rest of you would have shut down and not think through the question myself. And I know some of you would have not followed what he did and would have used a method that I would have shown you. True or false?
Sir, if Chevy didn't speak, I wouldn't do the question. Because I was
Okay.
thinking of the upper and the lower level, but then I didn't know where to go from there. So I was reading to see if there was something hidden in the writing at
question.
the top and then look at the graph. So when he said it, he actually gave me an idea of what to do.
All right, fair enough. And that's why speaking in class again, you learn from each other. So that's another testament. Okay, so other question now is there anybody in the class that did it the way that I just did it by saying 4 minus 1 over 6 and it's when it equals to a half? Anybody did it that way?
Yes, sir.
Yes, sir.
Yeah, good, because that is the way that sir taught you. Yeah, man, good. I'm happy about that. So the point I'm making is if you're going to the question in the exam and you see a question and I say, blow, how would I come in this? After the construction, you do. But in other question, you see the man bold the whole business about trapezoidal. Then bold it. That means they're talking about the trapezoidal rule. Uh-oh. Sir taught me the trapezoidal rule and I understand the trapezoidal rule. When I'm teaching, I don't teach per question, I teach concepts. So when I teach from grassroots concepts, it means that anything the man them fling at you, you're supposed to be able to do it. So you go back to the grassroots concept. If when you do the stuff, when you look at the stuff and say, all right, sir, say upper limit minus lower limit, b minus a over the number of trapezoids. The question never gave me the number of trapezoids, but as stagiaires say, him look on something and him say that those are trapezoids because they look equidistant because him say one start at 1, one's got a 1.5, them equidistant, so them are the trapezoids. So I'm going to divide it by 6. And then him say, come out, start the stuff, and you will see what is happening. And then the figure will make more sense. As you're doing the question will reveal itself. And the more you do the question, the more the question is just revealing itself, and the more you're seeing what the question is asking. So that's very good. And congratulations again, guys. It is, you guys will do well. So the width of the trapezoid there, yes, is going to be a half. Remember, it is going to be a half over 2. Shamari asked the question, sir, that 2 under the v of x will always be there? And the answer is yes. So it's going to be v of x over 2. So if I have a half divided by 2 is going to be a quarter. So it's going to result in that 1/4. So this 1/4 is going to multiply everything right here. So that's what it's going to be. And then now, the next method, the next step in my process would have been now to recall what the function is. And the next process is to work out my ordinals. So if I know that the width is a half and my lower limit is 1, it means that my next limit is going to be 1 plus a half. I get 1.5, 3/2. Then plus another half, I get 2. Plus another half, I then get 5/2. Plus another half, I get 3. Plus another half, I get 7/2. Plus another half, I get 4. Remember, I always start my ordinals. You see, all of them points I'm telling you, when I make sure to learn them, because the man have a way of putting some of these things in a multiple choice in a general form. You always start at the lower limit. You always end at the upper limit. You cannot end at a limit that is greater than what the question gave you. So it says between 1 and 4 is between 1 and 4. Let me give an example of how important that is. And something that I saw with my own 2 eyes some years ago. Went to check a virgin at home. And well, actually went to check his mother. And when I went to the mother, I was walking by and recognized that there was a house in a particular community that the base of the house was missing. You know, like, think of it. I want you to picture what I'm talking about. Think of the sill of your window. Think of your window, anywhere your window is or ends, the base of your window, wherever your base of your window ends in your room or in your living room. The wall from the ground outside to the base of the window was removed. And I stood up at the people in the fence and I said, "Blow, what can I solve with this?" And then they had plyboard, you know, I guess blocking a web so that people not looking at them house or not running at them house but them. And it amazed me. And I was saying to myself, I said, no, this don't make no sense. So when I catch the house now, I talk to the mother, I said, "This is something strange about I got to your neighbor, walk on." And she said to me, they got a loan to build, to expand on their property. But you know, some people, them have the button lines, you know, them boundary line, you know, especially if you live in a place, in a community that is being developed and you put the markers, but you decide, say, you want to get a little bit more space than your neighbor, so you go over your neighbor and change the markers. When the people them come to do the measurement, them recognize, say, them take a piece of the other people them land. And the people them say, "Yo, lick it off. Lick it off because it's not right." And I'm saying to myself, wow, these guys are crazy. So because of you trying to be dishonest, it's going to cost you more money now because you have to lick off that. Remember now, you know, so the top of the house would have had an overhang. So you have to go lick off piece of the top of the house again to build the house in its correct position. So it always pays for you to be honest at the first go. Always pays for you to be honest at the first go. What's the point I'm making? If I'm saying to you, I am building a new apartment, my property is at 3 Mountain View Avenue, Kingston Street, 137 rather, Mountain View Avenue, Kingston 3. But 137 Mountain View Avenue is just by the college. The high school has another address, 135. And there's another building to the left of the high school that is also owned by the Excelsior family. That is 133. So if you're talking about Excelsior Community College, now you don't have to say only 137. You can look at from 133, come up to 137 to where our side node adjoins Nannydale. If me did ever decide, say, me want to go over a piece more, I cannot do that, and the bank is going to lick off the one and say rebuild, just like the people them. See the moral here? The man them say between 1 and 4, it has to be 1 and 4. See here, you start at 1, you end at 4. You can't go beyond 1, and you can't go beneath 1, and you can't go above 4. So you have anything that you're doing will have to fall within the range that you're given, and the range is between 1 and 4. Just remember that. And I don't know why I'm particularly spending a lot of time on that tonight, but you have to remember the upper and the lower limit is your boundary. You can't pass it. Any interval you create must be created within that boundary. If not, the buttons are going to be wrong, and the bank going to tell you to lick it off. Property can't sell. And this is real talking about, because it's real life mathematics we're talking about. The question that we're talking about here is applications to integration. All right, good. So now, I know my functions are which is x squared plus 2.
Question, sir.
Go ahead, my love.
When that the intervals, the ordinals were given, do we still have to write them back?
No, but hold on. You are only assuming now that you knew what those ordinals were.
So we need to write them back.
Yes, please.
Okay.
Yeah, man. She asked an important question, and that's why I'm going through the question. Who I'm going through, because we only and let me ask you, Chev, how it is that you're able to figure out that those things are related to it? Is it that you started the question and you look at it and recognize that they are the same thing up top?
Well, sir.
I hear you.
All right. I saw that one of the x was 4 and 1 was 1.
Right.
Okay, all right. So there's much between those are the limits. So when I look in the graph there, I saw it starts from 1 to 4. So I said, oh, those are the ordinals, sir.
Right. Very good. So what I want you to do for me is, when you look at, based on what Shelby just said a while ago, when you look at the first one and you substitute in this thing and you get 3, and so hold on there. What's the 3 up here, so? And you go to 3.5. I mean 1.5. And you get 17 over 4. And so, but 17 over 4, 4.25. But a quarter is 0.25, so 4.25. And you catch a 4.25, say, all right, one more time, man. One more time. You catch 2. 2 squares are 4. 4 plus 2 are 6. And you catch a 6. Me not do no more. Come in over the whole of them I have been known. Well, actually, I may do one more. Come on, make sure I'm right. I'm going to jump to them. The 3. 3 is 9. Plus 2, 11. We are done. Done. Now, it's good right there, say no. Because this question here, really and truly don't worth 20 marks. Know that we see what all of this here means. Talk truth.
Sir, would you mind if we give this question still?
Say it again.
Sir, would you mind if them still give us this question?
Really?
And this was like 2019. Yeah, man. But so why I say that the question is because all we have to do right about now. Remember the next step of the question, you know. The next step of the question now is to all these values that I have in blue. The evaluation of our ordinals at the point is what it is that we're going to work with. So what we're going to do right there and then is to say 1 times 3 plus 2 times this, times this, times this, times this, times this, plus only 1 of 18. Or 16, or 16 or 18. 1 of 18. So you could jump all of what it is that we just did here, sir, and just jump to this point right here. That's the point I'm making. That's the point I'm making. All right? So there are 5 of you that answered me. 4 of you that answered me. No, 5. 4. Another 4 of you that answered me. 2 of you gave me One gave me 217 over 8. One gave me 27 and 1/8. But I also got 27 and 3/8 and 27 and 5/8. So the 27 and 3/8 and the 27 and 5/8, can you see the corrections that you needed to have made?
Yes, sir. Mm-hmm.
Good job. The other person, you can see it?
So I made a error in my substitution.
Okay, all right. All right. So when you send it as a crap, very close, but it's not a problem. Good. And that is it. That is it. It's a 1, 2, 3. Question. Go ahead, my love. Go ahead.
How we work out the percentage aspect now? We
Hold
just
on,
work
hold on.
the
I'll come into that, man. I'll come into that. I'll come into that, man. Come into that. All right. Before I reach the percentage, I want to ask an important question. Is there anybody in the class that is not following the question that we just went through a while ago? I know we did the question long, but I was explaining the stuff. Do we understand what is happening here now? We have a great appreciation of the question.
Yes, sir, I understand.
Yes, sir.
Good job. It's very important, guys. I want to be able to understand what is happening. All right. Now that I hear a yes, and I know you guys are true to self, I want us to talk about the percentage. How do you think we can calculate? So when we did the approximation, we are getting 27.125. But the actual integration is 27. We want to calculate the percentage error. What do you think we should do?
put the fraction over 100. But in this case, the 0.125 over 100 and minimum.
All right. So I'm going to find the difference. And the difference is going to be 27 minus 27.125 rather minus 27 is 0.125. And the original or the correct square footage or square units is 27. So I have to put it over 27.
Just scroll up to where the question is, please. I'd like to take a note of the wording.
Let me know when you finish. Finish?
Yes, sir.
All right. Do you understand that method? Yeah, no?
Yes, sir.
But there is an error method that we can use. I don't want to spend some time on that method. No. I want to spend some time on this method. So the trapezoidal rule error bound, the trapezoidal ruled error bound for the trapezoidal is going to be given by the absolute value of the trapezoidal. The E is for error. Error trapezoidal, because you have error Simpson, and you have error this, and you have error that. So this is error trapezoidal. It's going to be given by K, B minus A cubed over 12n squared. K, B minus A, all cubed, over 12n squared. What is K? I'm going to show you that. What is B minus? What is B minus A? Oh, but sir, B and A, no? The upper limit and the lower limit? Yeah. What is N? The number of trapezoids. All right. So we have the information. It's just a mere substitution now that we need to follow through. All right. So watch me. Watch me closely. So recall, our function is x squared plus 2. Our function is x squared plus 2. You know what B is. You know what B is. B is my upper limit. You know what A is. A is my lower limit. And we calculated it already. B minus A is going to be 4 minus 1, which is 3. We have that. We know, say 6 trapezoids. Where does 2 come from, sir? All right, who work it now? See the function here? X squared plus 2. I'm trying to remember, Shamari, if you had asked me that question in Calculus 1. When I was doing the integral of the exponential function and I have to differentiate the power and then reciprocate it. Remember, they asked me a question to say, why are we talking about integration, but we have to differentiate? You did ask that question?
Sir.
All right.
Yes,
See, come up, Papa. It come right back again. So I'm going to differentiate this function. When I find f dash of x, I'm going to get 2x. See it here? F dash of x is 2x. When I find the second derivative, I'm going to get 2. Because see it here? Such that the second derivative of the function is going to be less than or equal to the value of k. So k is when I find the second derivative of the function. So when I differentiate this, I'm going to get 2. So that's how the 2 come about, right? So the absolute value of the error, trapezoidal error, is going to be k times b minus a all cubed over 12n squared. This semicolon means such that the absolute value of the second derivative is going to be less than or equal to k. Anybody remember what absolute value mean? Let me see if in the front of me. What it suggests?
Taking the positive value of the answer.
I appreciate it, son. Very nice, Papa. So we are only concerned with the positive result. So if we did get -2 right there, so we're only concerned with the positive result because we're looking at the absolute value of the second derivative of the function. On the positive result, right? Good. So let's go now. So the error is going to be 2 times 3 cubes over 12 times 6 squared. 3 3 is 9, 9 3 is 27, so it's going to be 2 times 27, which is 54. 6 6 36, and 36 times 12 is 432. So my error is going to be 1/8. My error is going to be 1/8. Anybody see where that 1/8 come from? Anybody can appreciate that 1/8? Go ahead, Chevy.
So you have this long and make a go through that long something.
You know, Chef, guess what? Remember, Papa, I teach you something, I'm a want to understand something. I'll go through the something so that you can see exactly what is happening. Now that you see it, I can't fool you again. Right? Now that you see it, can't fool you again. So the error would have been 1/8. The error there would have been 1/8. I know that my actual integral of the error under the curve there would have been 27. Right? So the 27.125 that we got, that 1/8 we got was our error. This is what these developers do when they are getting work and they have to calculate the stuff. Them sit down and them have people like all you and me will come in and just do a little one something and say the plan. Come to one calculation for me. Make sure the calculation right, you know. I make you a little 50,000, I make you a little 200,000, a little one-off payment. And you sit down and do the calculation and then you convince the man and then you say, yeah, the man pay that and you're good to go and just make a quick money. All right? So yes. So this is how we calculate the error for the stuff. So that 1/8 there is going to be, because it did say percent, so the 1/8 times 100 now is going to give me 12.5%. So my answer, the answer that I got from my approximation would have been at 12.5% off. How does this work? Whenever the developer doing them construction, them have to make some leeway for errors, for gaps. You know, like when I go supermarket, you know, carry the exact $2,000. You carry 2,000, maybe 500. Because you go buy something right, you come to 2,000, you're not sure. So, you know, you have that money there. Yeah, man. So this is how the man them do them calculation. All right. So that's how we calculate the error for the stuff. So you can get a full question such as this. And the question, the questions on the exam paper are a little indifferent. They will ask you sometimes, to calculate the approximate the error under the curve. Boom, done. 10 marks. Or they may say the plan. Approximate the error, yeah. But more, approximate the error, yeah, but more also want to calculate the error. So some exam papers have the error on it, but I'm seeing many of the exam papers without the error, and I don't want to run the risk that them ask the error this year, and I don't show you how to calculate the error, right? But then they don't, I've not seen the error calculation on the paper. If I'm not mistaken, I think it's only one exam paper I've come across where them ask about error, right? But I'm doing it because I don't want it to come and you don't know how to do it. It's better to do it and it don't come and you're good to go. All right, now that we finish the question, boom. Are you understanding? Do you have a better grasp as to the whole trapezoidal now? Now that you do a past paper question, I mean, now we get with 20 marks. We feel a little comfortable.
Definitely, sir.
All right.
Yes,
I like
sir,
this. Go ahead, Papa.
question. The method 1 answer not supposed to equal to a method 2
Method
answer.
2.
All right, put it this
So
way.
you can go back over the error for method 2 for me when you say please.
Yeah, sure.
Sure, I got it.
Sure. How do I answer Shamari? Oh yeah, I have a good answer, Shamari. You know, you may have a little youth in your area where when say do mason work, and tell him say, come put up on fall cook for you, I want dog house, and then you say to yourself, say, that's the only thing you can put up, dog house and fall cook. And can't put up real house. And I'm not trying to be facetious. I'm just trying to bring across a point. Anybody get the point I'm bringing across it?
Yes, sir.
Not be accurate.
Right. Right. So when you use a level, it no level. Right? When a man build a house and you put your bottle of water upon your glass bottle upon the counter, your wine glass upon the counter. By the time you wake up in the morning, it slide off because the place no level. Yeah. So one method is way off. Let me ask you though. And it's not way off, but yeah. So one method is layman, and one method gives you a more accurate interpretation to what the question is, and which is the method 2. So a layman will come and say, boy, sir, subtract that over that and get this 0.46%. Okay. But when you look at this now, you recognize that the error as 1/8 is coming out. And you know that the answer that you got was 27 and 1/8. So you see, that 1/8 is not surprising to you. Up here, so you're not getting that information. So, sir, the developer can use this information. Yes, he can use it too. We can use this information, you know. But this one here is, no, is a cobbler. You have him on the site. Him a go render. Him can't lay block because it's go lean. But him can render. Him can flash. We're not gonna make him render. We're gonna make him flash. But the one you done yes or no, I'm gonna be the one who can render now and build the lintel and build the cantilever and do the thing.
Professional, sir. Professional.
Yeah, man. Yeah, man. You get the point me I make, man. Yeah. All right. So don't worry about it too much, Astanin and Shamari. You're good to go. All right.
So, sir, question.
Go ahead, my love.
The question says that if or or answer with the 27. So it gives you, so you know if you get the whatever is from 27, right? I would look at it and we say that it's 1/8. Why we couldn't just do the last part of this method by multiplying the 1/8 by 100?
And
That's
you
going through all the process.
and you wouldn't know before I showed you now that that came out like that. You see the point I'm making? So you wouldn't know that. And guess what? And sometimes, many times when you're doing this stuff, you're not going to know the actual area. Many times you're not going to know the actual area because remember, you know, the approximation is done really for those difficult areas that you really can't get. Final example, and then I found another question that I want to do for me.
But I remember you're supposed to go back to the arrow.
Oh yeah.
As the differential, the first one, the 2A.
Okay.
I'm not sure.
No,
Not
the first one.
where you got the A.
Which A? This?
No.
This A?
Right there.
No, this a type of error, my love.
Okay.
This not for the man. Hello, miss. You don't know how to differentiate.
Yeah, that's what I wonder where you get it from.
But just ignore it because you know it's enough for the function on the A night. That's the deal. Leave it alone.
All right.
All right.
So you need to go through.
All right then, cool. Yeah.
So go back on method one, let me say something.
Sure. If Oliver was here, I'd engage Oliver in this conversation. But maybe I can engage Shamari in this conversation. All of us, because right about now, Obi feel that you want to drive out tomorrow myself. I want us to have a real conversation. Guys, what I want to do, I want to make sure that you know you have a total appreciation of the topic so that when you get the topic and you get practical questions like this. You see, when the question comes straightforward, we not worry about it, you know. But when the question come in this practical sense, no application form or application wise, I have to make sure that you fully understand how to do the stuff. Case in point. So in one of my other disciplines that I studied, outside of mathematics, I get very upset when I'm driving on the north-south coast highway and I am passing, you know, in the money area where they cut through the hills to build this highway. And it also happens when you're, right. Because of how they just cut through the hill and they did not protect the surface that is now exposed. And that surface is now being exposed to all manner of weather that it wasn't ever exposed to before because it was inside of something. And as a result of it, now you have a lot of land slippage. When you're coming in, you will see how them have to, every minute they have to out there do work because they have a lot of land slippage. That is the cobbler work I'm talking about. Because when you shortchange a calculation, you have to go back and recalculate it. Once you do it one time, boom, you're good to go. So Astanil, I don't have to go through this method two again then, right?
No.
All right, watch me now. I'm giving you this question, an example two. And incidentally, we're going to do 3 questions today because I'm wrapping up this thing today now. There's nothing more to, the only time we're going to see this question again, one of the things I want to do, because calculus 2 is a lot on application. I will have to extend your thinking and ask lots of questions to be able to get the application out of you from what it is that we did, what it is that we did for Calculus 1. Calculus 1 was showing you how to do the calculations. Calculus 2 really now is the applications of those calculations. Watch me. Anybody remember when we're doing, no, let me not even remember, jog remember that way. The question here says, use the trapezoidal rule to estimate the integral dx over x between the limits 3 and 1 with 6 ordinals. How many trapezoids?
5, sir.
5, sir.
Very good. Very good. 5. Now, I'm going to challenge you. Challenge you now. This is quick and fast work. It's now 10 past 8. I'm going to give you 5 minutes at the onset to start this question to see how far you can go. But before you go there, let me go back to what I was going to ask you. When I have it as dx over x, what is the true function? Dx over x. I'll write it in a more presentable.
1 over
Go again, Shamari.
1 over x dx.
Very good, son. Very, very good. So the true function is 1 over x, right? Remember, the dx is always to the side of it, but I can multiply the dx and do anything with it. So it's really 1 over x. I'm giving you 5 minutes at the onset to see how far you reach the question, and I'll check in on you. Start working, please. Very good, guys. Proud of you. All right, how we stay?
I'll go on in, sir.
Okay.
Oh, still working?
Substituting, sir, substitute.
Yes, sir. Mhm.
All right, continue working. Very nice. I'm happy that you're still working. All right, continue working. Soon checking again. Hey, my people. Or are we finished now?
2 more minutes.
All right. Anybody else? Hold on. Some people drop off. Um,
Sir, I sent a message in the chat.
they sent a message in the chat and I've seen that.
Oh, okay, let me see.
Oh, sorry. Sorry.
No
I
problem.
forget. I forget. I was looking for the notification, but I forget that I'm keeping the chat open nowadays.
Oh, okay.
Oh, okay. Got you. Got you. All right. You want to leave now? You finish this off?
Yes, sir, I attempted it.
What you got for the answer?
Sir, I'm not sure if I'm right, you know.
No,
I
no.
got 1.11026 units square.
All right. All right. So if you're right, you can leave. If Mike, you don't get it right, him can't go nowhere. Mike, wait for your answer.
1.1102671 units square.
Okay. Shabby, wait it.
So everybody I use decimal.
Wait, you wait,
Fraction,
use fraction, wait it for your fraction.
1 and 206 over 2,520 units squared.
520?
Yeah. No, sir, 2,520 units squared.
All right, no problem.
See if
Okay.
it's equivalent to what they guys said.
Yeah, so work it out to the as a discipline to them, answer if you get the same thing like them do it.
So I got 1.110 units squared. Trying to work it as a fraction though.
Yeah. And I'm going to show you something, but don't kill yourself too much. Don't kill yourself too much. I would have said some things to you in calculus 1, but don't kill yourself too much about the fractional point, the fractional aspect of it now. Most likely we get the denominator today. Then multiply being a 2,000 and them something.
Yes, sir. Yeah.
Yeah, man. All right. All right. So 2 students will have to leave in another 2 minutes. So let me just go here and show you. Yes. So you're correct. 1.11026.751.
We have to use all of that.
You don't have to, but I'm using it so that people can see what them look like. What Tajay, that's you were giving some decimal place, and Michael went more decimal places than you, Taj.
Yeah.
You have these decimal places, Taj?
Yes, sir. I just stopped at 26.
All right, Mikey. You did give me more than Taj did.
Yes,
Were you?
sir. That's
So you
it.
have everything what you have. All right, good job.
That's it.
All right, guys, let me tell you something. I know this is one of the areas that is well appreciated and well understood by students whenever I teach it. I don't know why the Lord asked me to start here, so, but for now, I feel good. I'm very confident that you guys are understanding what is happening here. Utterly, I need to hear from you. I'm very confident that you guys are understanding what is happening here. Are there any dissensions? Any student that is not seeing? Well, let me just glance through the question quickly. So Taj and Mikey, if you have to run now, understood. When I upload the other recordings right here, when I upload the other recordings, you will see any additional questions that I've done. All right?
Okay, sir. We'll do. Thanks again.
Yeah, man, no problem. All right. So while those students would exit for other reasons, let us just quickly point out some of the main areas. Area number 1 is the upper limit minus the lower limit over the number of trapezoids. Remember, 6 ordinals. Let me tell you the common error over the years when I'm teaching this topic, and that's why I am very particular with what I'm saying now.
Some of you may be annoyed. I don't think you are, but somebody listening to the recording who understands the topic may say, so why am I have to say it so much time? The common error that students make when they're going to the exam, instead of putting this as 5, they use 6 because they see the word 6 right here.
Sir,
Yes, please.
that's exactly what happened
Yeah,
to me.
man,
I when I
yeah,
was about to find the intervals, but so hold on there.
yes, man. Chevy, you did that too?
Yes, sir.
Lord Jesus.
Well, dude.
You see, so this is why I say the things that I say over and over and over and over again. Because over the years, I would have had very good students who would have missed their A's because of this very error. Some students get a resit because of this error. And had they not done that one mistake, they could have passed the course even with a C minus. So I'm saying this to say to you again, and that's why I put this question right at this point. Don't look at the word 6 by itself. You have to look at the word ordinals with it as well. Because if it is 6 trapezoid, that means it's 7 ordinals, that means you're gone into something else. Ha! I never remember to ask you this question. So you know that I could do this question with 4 ordinals. Or I could do the question with 3 ordinals or any amount of ordinals. What if I'd use 3 ordinals? What do you think will happen to my answer? You know what? Don't answer. Don't answer me. All right, go ahead and answer. Answer me. Answer me.
It would be 3 minus 1 over 2. There's it's
All right. Okay. Yeah, but fair enough. All right. All right. I want you to do a quick exercise. I want you to do a quick exercise with me. I want you to do a quick exercise with me. And even at the expense of not doing the other question, the exponential question with you, it's not a problem. We can start that one at the start of next class. Because one of the things is I want to do a little one question before we start. So, I normally give a little grace period. So what I'll do, instead of waiting the 15 minutes or the 10 minutes, I will just put a question there. So we do that up front, before, whatever, we actually start the class. I want to do a quick something here. I don't want to tell you. I want you to discover it for yourself, because when I tell you, you're going to forget it. I want you to do the same question for me one more time. But this time around, I want you to use 4 ordinals. How many trapezoids?
3.
3 trapezoids, right? Do the question again for me, but this time use 4 ordinals. Quick and fast. I'm right here, so. And then if anybody finish it first, sir, we'll finish. And then we're going to have a conversation. And again, point it out. I really hope my point is proven from this exercise here. But if not, I'll just tell you what it is.
So,
Yeah.
alright, sir. So we'll be using the same limits.
Yeah, man. Same 3-1. The only thing that we're doing is changing the number of ordinals from 6 to 4.
Before.
Mm-hmm. What happened? Tim, what you thinking? Can work?
Okay, this might cause an error.
Bye.
Well, now, let me try still.
Yeah, man. Try it, man. Try to
Sure.
make we have a time. So yes, yes, my love.
I got 2.26 units squared.
You got 2.26 units squared. Okay. All right. The rest of you hurry up. Shamari, how if I reach Papa?
Right, don't get ordinals them now.
All right, cool. Simon, how if I reach Pops?
Sir, I calculating the area.
All right, good. Like 2 more minutes, and then we'll see what is happening, and we're going to have a conversation.
All right, sir. I don't know if this is correct now based on the rush.
Mm-hmm.
All right, so I got 1 and 41 over 250 or 1.39 units square.
Okay. That sounds a little closer to what is that I was 1.39. No,
Yes, sir.
1.39 squares. That's what he said.
Yeah,
Square, unit square.
Yeah.
That sounds actually closer to what I was looking at. Asini, were you able to look at your calculation or did you just stop?
I stopped.
Okay. Shamari, finish it, Papa. Simon, where you get?
So I got 1.130.
1.130. And Chevy, what is that again?
1.39.
1.39. Okay. Let me hear what Sham get. Arthur, you sleeping? Yep, she is. All right. Granty, waiting on you to put the icing on the cake.
Just a few more minutes, sir. Maybe 2
Yeah.
more.
2 more minutes. All right. So there's a point that I want to bring across, and what better way to do it than self-discovery? Yeah. Arsenal, in the meantime, Arsenal, I want you to look back at the calculations, because I guess, yeah, I can do that, and we can all check together. Yeah, so I don't have to do it. We can all check together to see that we are on the correct path. Yeah, that would be. Let me ask in the meantime, while Sean put on the final touches to the stuff. What were your ordinals I got?
For which one? The second one that we did?
Yeah, the one with the 4 ordinals.
1, 1 and 2/3, 2 and 1/3, and 3.
Everybody agrees with that? Them not answer. Them look over them. Chevy, you know, I agree with what Aston says. Wait, Simon,
Wait, repeat.
repeat. Aston, please.
1, 1 and 2/3, 2 and 1/3, and 3.
I like the silence, you know. We get nervous, you know.
Just because I have it in improper form. I need to convert it.
So in improper format, it would be 1, 3/1/3, and 2, 5/3, 7/3, and 3.
Yes, sir.
Yeah, I got those as well.
Good job. Excellent. All right. I was just about to get for my tablet to start writing. All right. Good. So I don't have to write. Excellent. You guys are calculus students. So good. All right. So we have the ordinals. We know the function. The function is, as a matter of fact, what is the width of the trapezoid again now?
2/3.
2/3. Good. So the width is 2/3. So we have 2/3 You have 2/3 divided by 2. So your fraction is going to be what?
Sir,
1/3.
right, that's all right, that's all
Ah, so
right.
you see what the teacher is doing? I know the critical points for which to check with everybody. So that's why I say I don't have to do the question because I know the critical points that I have to check. Very good. So yes, Sham, you're going to get 1/3 as that scale factor. Great. Now, what are they?
Sir,
Yes, Papa.
you know what I was doing earlier, sir?
Mm-hmm.
All right, we have that 1/5 up there.
Mm-hmm.
I was using the 1/5.
To multiply everything, to multiply this.
No, I was using to find the ordinal, sir.
Oh no,
You see it? They are throwing me off back then, sir.
no. Say it's a good thing. So we are do more of the questions. No man, none of that. To find the ordinals, we have to use the width of the trapezoid. We have to do the width of the trapezoid. This is what we're doing.
I get the 1.13 units squared now.
You get so you get the
I
1
probably
point.
made that mistake because I didn't write it out. I just used a different ink over the previous question.
Okay. Okay. Chevy, please make a notation so you don't make that mistake again, please, Papa.
No, man, sir, I thought what's that record, sir.
All right, so that's nice. I'm happy that you are you're seeing that now. All right, now. So what I want to have happen now is I still don't get a fulsome consensus. Sham's supposed to finish the thing by now. So is it 1.13 or is it 1.39?
I get the 1.13, sir.
All right, so Chevy, look at your 1.39 again and just check quickly because Shamari Sim getting 1.13, Asini getting the 1.13. Simon, what are you getting?
So I got the 1.13.
1.13. All right, so Chevy, based on the mistake, based on the mistake, all right, good. When you compare both answers now, what do you recognize? One you get 1.13. This one you get 1.11. What do you recognize? What are you seeing? No sight.
Other than the slight difference in unit based on the width.
Okay, and what slight difference are you recognizing? Let me see if that I could extend it and use that as an answer. What?
The decimal with the 1.11 and 1.
Yeah. We know
Like
that
a
you're talking.
0.2 difference. That's where I'm going.
Yeah, I know. We see that, man. But tell me now, and interpret that one for me. How you think you can justify that or relate to it or explain it? What's the significance of that? It is because of what? What do you think?
I'm gonna go off and say because we have we start with 6 ordinals versus 4. We know in mathematics it's 4 minus 2. There is just 2 numbers between the 2 ordinals. So in this case, it's 0.2 units.
So okay. So tell me now. So which one do you think is more accurate?
What and what?
So we did the same question 2 times. But one
Okay.
we use 6 ordinals and the other one we use 4 ordinals. We got 2 different answers, 1.11, 1.13. Which of them you think is the most accurate of the approximations?
Sure.
Which one the rest of you think is more accurate of the approximations?
One with the more cardinals.
Why?
No, I'll say
Or maybe the one with the less
same.
ordinals, because we have less room for error.
Oh, really? Let me hear Chevy finish his thought. Why Chevy?
Hold on, let's say, hold on.
Would it be because you have more data to work with, and so that the plot of land to divide up, it would have be divided up. You would have get like every little turn that the piece of land make.
Same here, so. Look at this here. You see I have three trapezoids right here, so?
Yeah.
If I were to give me one, if I were to break this trapezoid into, say, 1 into 3 pieces, so I drop in 2 more ordinals right here, so. If I drop in 2 more ordinals, I'm going to get 3 pieces. What is happening here is that this underestimation right here, so, is going to be reduced drastically. It's going to be reduced drastically because I'm going to go closer to this ordinal. So that means the trapezoid is going to use up more of this up here. Because remember, you know, say if I drop an ordinal right at this point right here, so just imagine that point to this point. When I draw the line that comes across to connect the 2 points of the ordinal, you see right there, so, and then a piece of the gap right here, so that I would take into consideration, talk truth.
Yes, sir.
All right. So what I'm saying to you is the increased surface area, as what Shamari said, every nook and cranny of the calculation you're going to take into consideration. So the more ordinals you have, the more trapezoids you have, is the closer the trapezoids is going to be less likelihood that you're making, if you're going to get closer to the actual integral of the function. You're going to get closer to the point where chances are when you increase the number of trapezoids, you will, and you do the approximation will come out to the actual integral of the function. It will come out to the actual integral of the function. Trust me, think about it. So that explains it. Why in one answer you get 1.13, but you get 1.11. 1.13 is further from the actual limit because it is going to be further from the actual limit because I have a greater we call it trapezoid. You know, it makes sense, you know. I'm going to tell you why I say it makes sense. If you're packing and if you know how to pack when you go foreign, you know not agree with me that one. I not figure out. Say I go, you leave from Kingston and go Montego Bay and you pack a suitcase to go Montego Bay. You know, like when you go hotel, yeah man, I don't want, you go there for 3 days, I don't want to carry one big suitcase, you want to carry one little suitcase. Only now go fold the clothes, so only go put the clothes in the something. Let me see if you know how to pack. You're going for a 3-day look or something, or maybe a 2-day or even an overnight.
In the roll fold.
Thank you very much, Astonil. You are going to be using the roll fold. So when you use a roll fold, you are actually smallerizing the stuff instead of biggerizing it. Does that make any sense?
Yes, sir.
Yeah, man. So you know, and I mean it happens. So even if you're using a bigger suitcase, you know, using a bigger suitcase and you just drop in something them, you know, you do a quick pack and you drop in something them, the shirt and the pants and just throw them in and don't follow them up, you recognize that you're not utilizing the space. And when we talk about the trapezoidal rule and the approximation, we are talking about utilizing the space to the maximum. So the greater the number of ordinals is the closer you get to your approximation. This ends the topic, hands down. Nothing more we can, there's nothing more that I can think of right about now that I can say, will dissect the topic in such a way that, I mean, any way, shape, or form, them give you the question, you're supposed to can mash it up. Mark, I have not yet done any of the exponential functions with it, but it's not a problem. The exponential function is treated in the same way as you'd have done with the questions that we've done before. You'd have still go and find your v of x, and still go and find the v of x over 2. You still go ahead and find the ordinals and still substitute it to the function. It's not a problem. So if they meet a logarithmic function or an exponential function, remember, I teach you conceptually. Follow the rules, and you should be good to go. That is it for me, Any questions? If not, big up on yourself. Questions?
No, sir.
All right. Big up on yourself. On Monday, we'll meet again.
Sir, you too, sir.
Have a good weekend, thanks.
To you too, yeah, man. Cool. Bye-bye.